Hi everyone, and welcome to the first video in my new Unreal Engine 4 tutorial series. I've had a number of requests over on Discord for a vaulting tutorial, so that is where we are going to start. Okay, so for this tutorial I have created a new third-person example project from the Unreal Engine launcher, and the only change I've made is to add a wall for our guy to vault over. And I've created a new animations folder and just imported a vaulting animation. To play the actual animation of the game, we're going to be using an animation montage. So if you right click on your animation, go up to create, and then create anim montage, then double click on it to open it up, and you'll see that the montage plays in something called a default slot. Now we need to make sure that our animation blueprint has this default slot, otherwise the montage won't play when we need to trigger it. So just hit save to save the montage, and then we need to find the animation blueprint. If you're using the standard third person example, you need to go into mannequin, animations, and then the third person anim BP. In here we need to make sure there's a couple of things are set up. We were looking for root motion over in the details panel, and we want root motion for montages only. And here in our anim graph you can see we don't actually have a default slot. So if you drag off from the state machine, type in slot and then montage default slot, that will create the slot for us. Hook that up to the output pose and just comment that default slot for montages. It's a good idea to get into the habit of commenting everything you do, because once your project gets bigger, it's a lot easier to see what your code's doing if everything is commented out. And when you come back to things after 2 or 3 months, it's a lot easier to work out what you've already done and what code's doing what. So that's it for the animation blueprint. Hit save on that, and then we can close that down. Okay, so we now need to create the logic in our character blueprint to allow him to vault the wall. There's a number of ways you can get the vaulting to work, but in this example, what I'm going to do is I'm going to have it so the character can jump normally. However, if he comes up close to a wall, instead of jumping over it, he's going to vault it. So find your character blueprint, and if you've already got some code in there for his default movements, so find the jump and just drag it out of the way so we've got a bit more space. We can get rid of the stop jumping, we're not going to need that, and we'll just disconnect the jump for now. Okay, so we're going to be using a line trace to detect the wall. So if we drag off of pressed, type in line trace, and we're looking for line trace for objects, you will see we need a start point and an end point. To create the start point, what we want to do is we need to create an arrow component on our character. So if we go into the viewport, select the mesh, add component, type in arrow, and call it vault arrow. This will create this red arrow down here. We need to rotate that round 90 degrees so it's facing forwards, bring it up to about the height of his knees. Back in the event graph, we can now drag off this arrow and get its world location. The world location will be the start point of our line trace. Okay, so we've got the start point of our line trace. Now to create the end point, if we get the forward vector from the arrow and extend that out in front of the character, we can do that by multiplying it by a float, let's say 100 units. If we add that to the start point of the line trace, we can create our endpoint 100 units in front of the character. set the debug type to duration so we can see it, and we basically need to tell the engine what we are searching for. So if you go into our map, find our wall, go down to collision in the details panel, and if we set that to custom, you will see object type, and our wall has a world static object type. Back into here, if we drag off object types, make array, and ensure this is set to world static. Now if we go back into the map, when we hit the jump key, the debug draw is drawing our line trace for us, which you can see. And if we come over to the wall, do the same thing, you'll see that red square there is our hit result. So we can see that our line trace is detecting the wall. Now we can take that hit result and we can do a number of things with it. First thing we want to do is create a branch, and the condition of the branch is it returns true if we get a hit, otherwise it returns false. So if it returns false, we hook that up to our jump. Now what will happen is we can jump again, come over to the wall, and because we're getting the hit, the character isn't jumping and instead will vault the wall. So we know that is now working. Okay, so to create the endpoint, if we drag off the vault arrow, get the forward vector, we can take the start point of the arrow and basically create a line trace in front of that start point by timesing this by a float, and this will be the length of our line trace, so let's make it 100 units. If we add it to the start point, I want a vector plus vector, not a vector plus a float. That will give us the endpoint of our line trace. Debug draw, that needs to be set for duration for debugging purposes while we test it, and we need to tell it what sort of objects we're actually tracing for. So back in the third person map, if we click on our wall in the details panel, if we go down to collision, if you set that to custom, you will see the wall has an object type of world static. So back in our character, drag off of object types, make an array, and ensure that array is set to world static. Now what will happen is, when we hit the jump key, you will see this red line, which is our line trace. And if we come over to the wall, when we get a hit, there will be a little red square. There it is. Come away from the wall. It's not detecting anything, so it doesn't return a hit. So with this, we can do a number of things. We create a branch from the return value. True means we've detected something. False means we've not got a hit and not detected anything. So if it's false, we can then jump. Back into the map. Jumping is now working again. Come over to the wall. Because we've got that hit, the character can't jump. Right, so if we drag off the out hit and we break that hit result, you can see we have got a lot of information which the engine is calculating for us. We don't need all of it. What we do need to do though is we need to right click on location, promote that to a variable. You can change the name if you want, but basically that is the world location of our wall. And we also need the normal. So the normal is basically the direction the wall is facing. It's a bit hard to explain, but what we're going to do basically is rotate our collision capsule later on to the normal location of the wall to ensure that when the vault animation plays, the character is in line with the wall, so he doesn't vault over it at an angle. So promote the normal to a variable as well, and ensure they're both set from the true branch of the line trace. So that is the information we need from this hit here. So we can close that down. And my engine crashed, so I've already done this, but I've changed the comment to wall line trace instead of jump. Next thing we're going to do is we are going to make sure the wall is not too high to vault over, because if we've got a ridiculously high wall, then it's going to look a bit silly if the character jumps 10 foot in the air to vault over it. Okay, so now we need to do another line trace. Oh, I can't spell. Line trace for objects again, and this time it's going to be to detect the height of the wall. So to do this, if we grab our wall normal, get the rotational data and make rot from X, and get the forward vector. If we times this by a negative value, so vector times float, and make this negative, 10 units should be enough. That will basically take it back over the wall. So we are line tracing over the wall rather than behind the normal, rather than in front of it. If we get the wall location and we add these two together, so vector plus vector, then this gives us a location above the wall. So if we then add, say, 200 units in the Z axis, that will give us our start location. And if we take that location minus a vector and we go, say, 200 units down, that will give us our end location. Again, we need to make an array, world static, and debug draw for duration again. Now what's going to happen is, if we play, we're going to get 2 hit results when we're near a wall, and you can see it has detected the height of the wall. There we go. So the lower square is our wall line trace, and the upper square is our wall height line trace. So from this, what we want to do is, again, we want a branch, because we only want to carry on if we get a hit. And again, we want to drag out from the hit, and we want to break that hit result because we need some more information. This time we want the location, but instead of calling it location, what we want to do is we want to call it height, or wall height, and make sure that is set on true. Okay, so now let's create a, first we'll comment that. That's the wall height line trace. Then what we'll do is we will do a couple of things. So now we're going to take that wall height data and make sure that our guy can vault. So if we put a sequence in, this will allow us to perform the check before we move on to the next part. So we are going to need a branch, because we are going to set a couple of variables here. So if we get our wall height minus its location, and if we subtract location from the height, break this vector because we only need the height data, which is the z-axis. And then if this is greater than, let's say, realistically 60 units, we will set a condition that if it's true, if we create a variable which will be a Boolean, oh, we don't want it to be, there we go, can't volt. So if that's true, our guy can't volt. If it's false, our guy can volt. Okay, so this is basically checking the wall height. There we go. And then we need to do one more line trace. I promise you it's the last one. And this is checking basically the depth of the wall. Because obviously if the wall is too deep, it will look ridiculous if our guy tries to vault over it, because he will land in the middle of the wall and fall inside the wall. So what we need to do is, if we drag off of this and we do a line trace again for objects, if we create a reroute node, you can tidy that up a little bit. Need to create a bit of space. Okay, so now what we're going to do is we're basically going to make sure the wall isn't too thick for us to vault over. So for this final line trace, we're going to copy the code from the wall height line trace, paste it in here, make an array from the object type, which again will be world static, and set the debug draw to duration so we can see what's going on. Then if we plug that one into the start, that one into the end, and just adjust these values, so we're going to be tracing back from the normal point, let's say 50 units. Let's make this 300, then we'll take 275 away. So what we're now looking for is a line the other side of the wall which isn't going to hit anything, because if we get a hit, it's not going to let us vault. So there you see we're going in further than the wall, the height of the wall, the depth of the wall, and we're not getting a hit, so that will let us vault. So let's comment that one out. Wall depth, line trace, and we're going to take that hit result, have another branch. This time we're going to come off the false though, because we don't want the hit. If we get the hit, what we could do is we could break that hit, get the location again and store that as another variable. And that would allow us to do something else, like maybe climb up onto the wall, but that'll be a different tutorial. So now if we don't get a hit, we want to make sure we can vault. So we get that one, another branch, and again we're coming off the false. And what we're going to do now is we're going to rotate our capsule, our character, to face the wall. So we're going to set the actor rotation, and we're going to get the wall normal. From the wall normal, we basically need the Z axis, the yaw, so we're going to make rotator from X, I'm going to break this rotator. And we are going to add 180. So float plus float to this. And then if we get our actor's rotation, go out to rotation. If we right click on the return value, we can split that struct pin, take the X and make a new rotator. And we'll also take the pitch, which is the Y, and we'll use this as our yaw. What should happen? Plug into the right one might help. Plug it into the new rotation. What should happen now is, if we can vault, it should rotate our character to face the wall. There we go. So that means our montage will play properly. A couple more things to do. Take the capsule component, set the collision. This will allow the capsule to pass through the wall if it clips at all. Make sure that's set to no collision. Character movement, set the movement mode. If we set this to flying, it will allow the montage to move our character, sorry. Okay, so let's move this out. Let's grab it all, make sure we grab it all. Move this out of the way, and then we'll comment that, and we'll call this set rotation collision and move mode. Right, I promise you we are almost there. The final stage is just to move the player's character across the wall while the montage is playing and then reset the collision. So if we go back to wall depth line trace, copy that bit of code there, because that is basically what we need here. And instead of that, 60 should be enough. Right, instead of tracing, we're basically just going to move the capsule. So if we break this vector, we're going to take the X and the Y from here. So if we remake it, so make the vector and just take the X and the Y, we are going to take the wall height, and we're going to just minus a little bit from that. So say 10 units should be enough. Break this vector, and that will give us our Z. So if we come off of set the movement mode, set actor location, there it is. This will be our new location. So while the montage is playing, the player character is going to be moved across the wall. Then if we play the anim montage, select your vault, and then the last step is to put in a delay which lasts for the duration of the montage. If we take the set collision and set movement mode from here, we can then give the player his collision back. So set that to collision enabled and set the moving mode back to walk in. And I think that should be everything. So if we comment that, move character, play montage, return collision and movement mode. That should hopefully be everything. Let's just check. Yep, I think so. Let's just make sure go back to our mesh, to the viewport. Camera boom. We don't want the camera clipping through the wall when the mesh moves through it, so if we go to socket offset on the Z axis, maybe move that up to say 50. Maybe move it out a little bit, 25, so it's a bit offset. Give you a bit of a better view. Could even maybe move it a bit higher. We might have to move it a bit higher, we'll see. And then in the animation, thinking about it, go into our animation, down here, make sure enable root motion is set to true. If you don't do that, what is going to happen is the character will vault the wall, but then because the root motion wasn't set to true, he'll be pulled back through the wall to his original start location. So make sure that's set to true and make sure it's all saved. Now if we hit play, come over to our wall, hit the space bar, and we vault over it. If it's too high, we don't vault. If we're too close, we don't jump. And if we're not near a wall, we jump. So I hope that's been useful, guys. That'll do it all for this one. I will see you in the next tutorial, hopefully coming soon. Thank you very much.